Welcome to another episode of learning. I thank all of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held in the month of March 2025 for Assam State. It is a rescheduled examination for Assam State. Today, we will discuss the solution of a problem from the section Linear Algebra, and it is related to the concept of diagonalizable matrix, and the question is placed in part B, which is a multiple choice question, and it carries 3 marks. Its question ID is 706509. This question is suitable for all these examinations. Right. The given question is, let A be a 3 by 3 complex matrix such that A cube is the identity matrix. Which of the following statements is true? We are given 4 options. Option 1, A is diagonalizable. Option 2, A has at least 2 distinct eigenvalues. Option 3, the characteristic polynomial of A is x cube minus 1. Option 4, the minimal polynomial of A cannot have degree 2. Let us now discuss the solution of the problem in detail. We are given A is a complex matrix of order 3 and A cube is identity. Right. We give a counter example for 2 of the options. Let A is equal to the identity 3 by 3 identity matrix. Then A cube will be I. Right. Now the characteristic polynomial of A, we know we write it as determinant of A minus lambda I, where A is I, that is determinant of I minus lambda I, and that is the determinant, 3 by 3 determinant, whose first row is 1 minus lambda 0, 0, 0, 1 minus lambda 0, 0, 0, 1 minus lambda. Now the determinant value is 1 minus lambda whole cube. So that is the characteristic polynomial of A for this matrix A, for which A cube is equal to identity, is 1 minus x whole cube. But it is in option 3, the characteristic polynomial of A is x cube minus 1 is given. Therefore, option 3 is not true in general. Right. Now, we have the characteristic polynomial. We can write down characteristic equation of A. That is, the characteristic polynomial is equal to 0. That is 1 minus lambda whole cube is equal to 1 is equal to 0. This will imply lambda is equal to 1 repeated thrice. So 1 is the only eigenvalue of A. And in option 2 it says A has at least 2 distinct eigenvalues. Therefore, option 2 is not true in general. We continue in the next slide for the remaining options. Option 1 and option 4 is remaining. Right? we have a complex matrix of order 3 and A cube is equal to identity. This means the polynomial x cube minus 1 annihilates a. And if lambda is an eigenvalue of a, then it will be lambda cube is equal to 1. It means lambda is a cube root of unity. What are the cube roots of unity? 1 omega square. Lambda can be 1 omega square. Now, m suffix a bracket x, max, which stands for minimal polynomial of a, divides x cube minus 1. Then, what are the possible minimal polynomials of a? It can be x minus 1, x minus omega square, and x minus 1 into x minus omega. It can be x minus 1 into x minus omega square into x minus omega into x minus omega square, and all three, x minus 1 into x minus 1 into x minus omega square. So the possible minimal polynomials, 7 are there. Right. But notice that all these minimal polynomials of A are products of distinct linear factors. We recall a result what we have studied. A matrix A belongs to Mn over C is diagonalizable over the field of complex numbers if and only if its minimal polynomial splits into distinct linear factors. So using this result, A is diagonalizable. Thus, option 1 is true. Now, note that we have 3 minimal polynomials of A of degree 2, and they are x minus 1 into x minus omega, x minus 1 into x minus omega square, and x minus omega into x minus omega square. These are the 3. And the option 4 says the minimal polynomial of A cannot have degree 2, but we have 3 minimal polynomials of A whose degree is 2. Thus, option 4 is not true. Right. Summarizing all the options, the answer to this question is option 1. That is the detailed discussion of the solution of the given problem, which is based on concept of diagonalizable matrix from linear algebra. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. I thank all of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, we'll definitely meet you all in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.